In this lesson, we're going to look at the different ways of solving systems of equations and when the best time to use those are. So the first way that we learn to solve a system is by graphing, and the best time to use graphing is to estimate solutions. So since your line has to be exactly where it needs to be and it can't veer off the path even the slightest bit, graphing does not usually give you an exact solution, so we usually only use graphing to estimate. The next one we learned was substitution, and the way to know if substitution is the best method is if one of the variables in either equation has a coefficient of 1 or -1. So that means that if you see an x by itself or a y by itself, it can be positive or negative. So in this equation, we would want to solve for x. In the next equation, we would want to solve for that y. But if there is a variable that has a coefficient of 1 or -1, then substitution would be the best method. The next one is elimination using addition. So if one of the variables has opposite coefficients in the two equations. So that would be a system like 2x minus y, or let's not say y, but let's say 3y equals 7, and 2x plus 3y equals 3. In this equation, the y values have opposite signs, so you could use addition to solve that system. The best time to use elimination using subtraction is if it has the same coefficient in the two different equations with the same sign. So in that same example, you could use subtraction to cancel out the x values. So here, since the x values are the same, you could use subtraction to cancel them out. So if none of the other methods work, that would be the best time to use elimination with multiplication. So if none of the coefficients are 1 or -1, and neither of the variables can be eliminated by simply adding or subtracting the equations, then you would want to use multiplication. So we're going to look at this system, and we're going to determine the best method to solve the system of equations. So looking at this one, we're going to look at the coefficients of both the x's and the y's in each equation. Since neither of the coefficients x or y have the same number in front, or additive inverses, meaning the same sign with a different, or the same number with a different sign, we can't simply add or subtract to eliminate. Also looking through there, none of the x's and none of the y's have a coefficient of 1, so since it didn't meet any of these qualifications, the best method is to eliminate with multiplication. So looking at this system, I can choose whether I want to eliminate the x or the y, and then I want to find a multiple to use to do so. So what I'm going to say is, if I look at the second equation, I notice that it has a positive 2 in front of the y, and I can make that match this 4 but with a different sign. So if this y value in the first equation is a -4, I want this to be a positive 4. So to get that to be a positive 4, I'm going to multiply by 2. So I'm going to simply rewrite the first equation, and then I'm going to multiply everything on this bottom row by positive 2. So 2 times -8x is -16x, 2 times 2y is positive 4y, and 2 times 19 is positive 38. So now looking at this system, it's the same system. I've just changed the second equation so that each of the numbers is twice as big. Now, those two numbers, they're both 4s and they have opposite signs. So what I would do to eliminate this is to add. And if I add that one to eliminate, I'm going to have to add everything else as well. So for the x values, I have 2 plus -16, which is -14x. And over here, I have 4 plus 38, which is going to be positive 42. So I have -14x equals 42. To solve this, I'm going to divide both sides by -14. That'll leave me with the x by itself. And then 42 divided by -14 is -3. Now I have my x value. I'm going to choose one of those original equations to plug it back into. So if I choose the top one because it has slightly smaller numbers, I just want to make sure that I plug this into the correct place. So this is an x value. I want to make sure I plug it in where the x goes. So that'll be 2 times -3 minus 4y equals 4. And then I'm going to simplify. So I'm going to do that multiplication. 2 times negative 3 is negative 6. So negative 6 minus 4y equals 4. Working through solving this, the first thing I need to do is move this 6 by adding it to both sides. Then I have negative 4y equals 10. Now, to get that y by itself, I'm going to divide by negative 4, and y equals negative 2.5. So decimals are numbers too. They can be part of an ordered pair. So the ordered pair that goes with this system is negative 3, negative 2.5. So that would be the solution to the system. If I plug it into the other equation, it would also work. So let me do that to check it. So I'm going to plug it in. Negative 8 times x plus 2 times negative 2.5. So I'm just going to plug it into that left side. I hope that I get 19 out. So negative 8 times negative 3 is positive 24. And then 2 times negative 2.5 is negative 5. So now I have 24 minus 5, which is 19, and that checks out. So that is the solution because it is the same point on both lines. So looking through these, we can figure out what the best method would be to solve the system by looking at each equation. So on this first one, I notice that both of the y's have a 7 in front. And since they both have a 7 in front, elimination is going to be my best method. Now I just need to figure out what type of elimination. So since these have the same sign, they're both positive, the way that I would cancel them out is with subtraction. So I'm going to subtract everything on this bottom from everything at the top. So this is elimination with subtraction. I'm not going to go through it to solve it, but you would use elimination to subtraction. That would get you there the fastest. All right, looking at this one, all the coefficients are different numbers. There's a 3 on one x and a 5 on the other, a 4 on one y and an 8 on the other. And none of them have a coefficient of 1. So the best method for this one would be elimination. And since the coefficients don't match yet, I'm going to be using multiplication. So one way I could do it is by multiplying everything on that first line by 2, and that would make both of my y's have an 8 in front. One would be negative and one would be positive. All right, so looking at this next one, what I notice is that I have an x with a coefficient of 1 and a y in the second equation with a coefficient of 1. I also have this y with a coefficient of negative 1, but since I have positive options, I'm going to stick with one of those. So I would solve one of these. I would just choose one to solve for. If I choose to solve for x, I would add y to both sides. And now I have the equation x equals 9 plus y. So that's set up and ready to substitute. This is a substitution problem. Substitution would be the best method. So since there was a variable with a coefficient of 1, substitution is the best method. So looking at this one, I don't have coefficients that match. I have a 5 and a 3, and then in the next one I have a negative 1 and a positive 2. So since this one has a coefficient of 1 or negative 1, substitution would be the best method. So while these are the best method, meaning it would be the quickest way to solve it, that does not mean that it is the only method to use. So you could still use any of the methods to solve these equations, it just might take some more steps. The next thing we're going to look at is how to write systems of equations to help us with word problems. So in this situation, at a sale, Seth bought 4 t-shirts and 3 pairs of jeans for $181. At the same store, Jenna bought 1 t-shirt and 2 pairs of jeans for $94. The t-shirts were all the same price and the jeans were all the same price. Write a system of equations that can be used to represent this situation. So what I notice here is that I have 2 totals. I have that Seth spent $181 and that Jenna at the same store spent $94. And what both of them were buying were t-shirts and jeans. So what I need to do is I need to find a variable to represent each of those. So for t-shirts, just staying with what we've been doing, I'm going to use X for t-shirts, and I'm going to use Y for jeans. That doesn't mean that those are the only variables, but those are the ones that I have defined. So what I don't know is the cost of t-shirts and the cost of jeans. So I know how many they bought. Seth bought 4 t-shirts, so that's going to be 4 times however many t-shirts he bought. And he bought 3 pairs of jeans, so that's going to be 3 times however much jeans cost. When I add those together, that's going to give me a total of $181. So Jenna bought 1 t-shirt and 2 pairs of jeans for $94. So looking at this system, we need to figure out the best method to solve. So since I see that the second equation has a variable that has a coefficient of 1, that would be a 1x, substitution will be my best method. So to use substitution, I would take this equation, x plus 2y equals 94, and I want to get this x completely by itself. So all I have to do to get that x by itself is to subtract 2y from both sides. So now x can be replaced with 94 minus 2y. So now I'm going to use that in this other equation. So the other equation was 4x plus 3y equals 181. I'm going to replace the x with 94 minus 2y. Then I just copy down the rest of the equation like it was. So what I need to do is I need to distribute. So first I have 4 times 94. I'm going to pull up my calculator to help me with that one. 4 times 94 is 376. I'll put it away for a little bit. So then I do 4 times negative 2y, and that's negative 8y. So plus 3y equals 181. So I distributed as my first step. The next step is to look for like terms. So I have negative 8y plus 3y. So whenever I combine those, I'll have negative 5y. So the next equation is 376 minus 5y equals 181. So the next thing I need to do is to subtract 376 from both sides. And I'm going to use a little iPad magic to move this up so I have a little bit more room. And maybe I'll resize it as well. There we go. All right, so now I need to do 181 minus 376. So 181 minus 376 is negative 195. So that cancels. I have negative 5y equals negative 195. So the last thing I need to do to get this y by itself is to divide by negative 5. So negative 195 divided by negative 5 is 39. So y equals 39. So in the context of this problem, y stood for the cost of jeans. So with this, we now know that jeans cost $39 because y represented the cost of jeans. To figure out the cost for a t-shirt, I'm going to plug that back into either equation. Since Jenna bought less items, that looks easier to me. So I'm going to use x plus 2y equals 94. And then I just want to replace the y with this 39. So I know she bought 2 pairs of jeans, which cost $39 each. And whatever's left over is how much she spent on the t-shirt. So if I multiply 2 times 39, that tells me that she spent $78 on jeans. And then I'm just going to take that away from her total of 94. So I do 94 minus 78, and that gives me 16. So that says that 16 was the price of a t-shirt. So t-shirts cost $16. So let's look at this next problem and figure out how to write this system. So this one says, Taylor has saved dimes and quarters in her piggy bank. So far, she has saved $4 and has 25 coins. Define the variables, write a system of equations, and determine the number of dimes and quarters. So the two things I need here, my two variables are going to be dimes and quarters. And more specifically, it's the number of dimes and the number of quarters in her savings, in her piggy bank. So these are going to be my variables. I'm going to say I'm going to use X for dimes and Y for quarters. So I know that on this other side it's going to be the total. So if we just think about that table that was up in the previous problem, this can help us set up our two equations. And then I want to think about what type of totals I had. So there were two totals. The first total was the amount of money. So like the amount of money that she had saved was $4. The second total we have is the number of coins. So that is 25. So anything that goes into this equation that's equal to 4 should be about how much it's worth, how much each one is worth. So if I think about a dime is worth 10 cents. So I'm going to say 10 cents per dime plus a quarter, which is worth 25 cents. So 25 cents per quarter is going to be equal to $4. The next thing is just the number of coins. So if I think about the number of dimes, that's the thing that I assigned the variable X to. And the number of quarters I assigned Y to represent. So the system here are these two equations. 0.10 X plus 0.25 Y equals 4. And X plus Y equals 25. So these two equations are my system. So looking at this system that I've written, now if I'm going to solve it, I want to think about what the best method would be. So the best method to solve this system, since I have an X and a Y with a coefficient of 1, the best method would be substitution. However, you can use any method to solve. So if I'm going to use substitution, then I need to take this equation that has coefficients of 1, so that's X plus Y equals 25, and I'm going to solve it for either one. I can solve it for X or I can solve it for Y. So let's say I'm choosing to solve this for X. If I want to do that, I need to subtract Y from both sides, and now X equals 25 minus Y. So I can plug this in for the X in the other equation. So in the other equation, I'm going to start off just by writing it. So the other equation is 0.10 X plus 0.25 Y equals $4. And for the X, I'm going to plug in this new expression. So 0.10 times 25 minus Y plus 0.25 Y equals $4. And then I want to solve from there. So first I need to distribute. So 0.10 times 25 is going to be 2.5 minus 0.10 Y is what comes out of the distributive property. Then I just copy down the rest of the equation. So after the distributive property, I'm going to check and see if there's any like terms. And there are two values that have a Y with them. And I'm going to combine those. So negative 0.10 Y plus 0.25 Y would be 0.15 Y. So this will be 2.5. Since that's a positive 0.15 Y, that's going to be plus. All right, so now I'm going to keep working through this. I'm going to subtract 250 from both sides. So if I had $4 and I take away 250, I'm going to be left with $1.50. That'll be 0.15 Y equals $1.50. So if I divide both of these by 0.15, this is Y equals, and 150 divided by 0.15 is going to be 10. So now I know that Taylor has saved 10 quarters. So 10 quarters is what that means. So now if I look at these two equations, the number of coins is definitely going to be easier. So X plus Y equals 25. So if I know that Taylor has saved 10 quarters, I need to know how many dimes are in that collection. So if I plug it into this equation, I can find that the number of dimes is 15. So this would be 15 dimes. We can check our solution by plugging it into the other equation. So 15 dimes times their value of 10 cents would give me $1.50 from the dimes. 10 quarters, which are worth 25 cents a piece, would be $2.50 from quarters. So if I add those together, that's $4 total. I have the correct answer.